Whether you're just starting chemistry or prepping for an exam, there's one skill you absolutely have to master: dimensional analysis and metric conversions. In today's video, we're going to walk through some of the most important and commonly tested conversion problems you'll see in chemistry, physics, and even real life. I've broken the problems into clear categories, and for each one, I'll show you how to set it up, cancel the units, do the math, and check your answer with the correct sig figs. So grab your calculator, pause when you need to, and let's really understand how dimensional analysis works from the ground up. Let's get started. For metric prefix conversions and dimensional analysis problems, the best way to problem solve is to create a unit map, list all the conversion factors needed to go between the units, and then set up the units so they cancel based on the given or starting value and unit. The first category will have single-step prefix conversions to base unit conversions. These are the simplest problems where you start with a prefix unit and convert directly to the base unit, and the base unit can be meters, grams, liters, or seconds. For example, we could convert from microseconds, the prefix unit, to seconds, the base unit, or milligrams, the prefix unit, to grams, the base unit. For this question, we are converting kilometers to meters. Since we are starting with the prefix unit kilometers and converting to the base unit meters, this will be a single conversion. On our unit map, we write kilometers to meters, and the conversion factor is 1,000 meters per 1 kilometer. Our given value is 5.2 kilometers, so we write it as 5.2 kilometers over 1 to be able to have a top and bottom to cancel out units. In the next fraction, we place 1 kilometer on the bottom and 1,000 meters on the top. The kilometers cancel out and we are left with meters. We have the unit we need for the final answer. Multiplying 5.2 times 1,000 gives 5,200 meters, or in scientific notation, 5.2 times 10 to the third meters. For this question, we are converting 1,500,000 microseconds to seconds. We are starting with microseconds, which is a prefix unit, and we are converting to seconds, which is the base unit. This will be one conversion from microseconds to seconds. So on our unit map, we write microseconds to seconds, and the conversion factor will be 1 second for every 1 times 10 to the 6 microseconds. We start with 1,500,000 microseconds over 1. In the next fraction, we put 1 times 10 to the 6 microseconds on the bottom and 1 second on the top. The microseconds cancel out, and we have our end unit seconds that we need for the final answer. Dividing the values, we get 1.5 seconds. If you like the move the decimal method, micro, or 10 to negative 6, means we move the decimal 6 places to the left. It will give you the same answer. For this question, we are converting 450 milligrams to grams. We are starting with milligrams, which is a prefix unit, and converting to grams, which is the base unit. This will be one conversion from milligrams to grams. So on our unit map, we write milligrams to grams, and the conversion factor will be 1 gram for every 1,000 milligrams. We start with 450 milligrams over 1. In the next fraction, we put 1,000 milligrams on the bottom and 1 gram on the top. The milligrams cancel out, and we are left with grams, the end unit that we need for the answer. Dividing 450 by 1,000 gives 0.450 grams. Here's a quick confidence boost checklist that you can keep in the corner of your notes while you're working on problems. We're always going to start with the given number over 1. Build a unit map you can trace with the correct conversion factors. Put the next unit where it cancels the previous one. Multiply all top values and divide by the bottom values. And round at the end. And don't forget to label your final unit. Now it's your turn. Pause the video and try this question. Convert 0.085 kilometers to millimeters using dimensional analysis. List your conversion factors, write your unit map, and drop your final answer in the comments with correct sig figs. For the next category, we have two-step prefix to prefix conversions. These require going from one prefix unit to another by passing through the base unit. For example, if I wanted to convert between kilometers and centimeters, I would have to use meters, the base unit in between. And for gigabytes and kilobytes, I would need the base unit bytes to convert in between. For this question, we have convert 2.5 kilometers to centimeters. Here we are converting between two prefix units, kilometers and centimeters, so we will first go to the base unit meters and then to centimeters. Our unit map is kilometers to meters to centimeters. The first conversion is 1,000 meters for every 1 kilometer, and the second is 100 centimeters for every 1 meter. We start with 2.5 kilometers over 1. In the next fraction, we put 1 kilometer on the bottom and 1,000 meters on the top. In the next fraction, we put 1 meter on the bottom and 100 centimeters on the top. The kilometers cancel out and the meters cancel out, so we are left with centimeters, the unit we need for our final answer. Multiplying and dividing all values, we get 2.5 times 10 to the 5th centimeters. For this question, we have convert 4.1 gigabytes to kilobytes. We are converting between two prefix units that have the same base unit. Gigabytes and kilobytes both have the same base unit, bytes. Our unit map is gigabytes to bytes to kilobytes. The conversion factors are 1 gigabyte is 1 times 10 to the 9th bytes, and 1 kilobyte is 1,000 bytes. We start with 4.1 gigabytes over 1, and in the next fraction we put 1 gigabyte on the bottom and 1 times 10 to the 9th bytes on the top. In the next fraction we put 1,000 bytes on the bottom and 1 kilobyte on the top. The gigabytes cancel out and the bytes cancel out. We are left with kilobytes, the unit we need for our final answer. Multiplying and dividing all values, we get 4.1 times 10 to the 6 kilobytes. For this question, we have 0.0045 kilograms to milligrams. We are going from kilograms to milligrams, so we will go to the base unit grams. Our unit map is kilograms to grams to milligrams. 1 kilogram is 1,000 grams, and 1 gram is 1,000 milligrams. We start with 0.0045 kilograms over 1. In the next fraction, we put 1 kilogram on the bottom and 1,000 grams on the top. In the next fraction, we put 1 gram on the bottom and 1,000 milligrams on the top. The kilograms cancel out and the grams cancel out. We are left with milligrams, the unit we need for our final answer. Multiplying and dividing all values, we get 4,500 milligrams. In the next question, we have convert 0.075 kiloliters to microliters. We are converting from kiloliters to microliters, so we will go to the base unit liters. Our unit map is kiloliters to liters to microliters. 1 kiloliter is 1,000 liters, and 1 liter is 1 times 10 to the 6 microliters. We start with 0.075 kiloliters over 1. In the next fraction, we put 1 kiloliter on the bottom and 1,000 liters on the top. In the next fraction, we put 1 liter on the bottom and 1 times 10 to the 6 microliters on the top. The kiloliters cancel out and the liters cancel out. We are left with microliters, the unit needed for the final answer. Multiplying and dividing all values, we get 7.5 times 10 to the 7th microliters. For this question, we have a shipping company accepts a package that weighs 0.0023 megagrams. How many milligrams does the package weigh? We are starting with megagrams and converting to milligrams, so we will go through the base unit grams. Our unit map is megagrams to milligrams. 1 megagram is 1 times 10 to the 6 grams, and 1 gram is 1,000 milligrams. We start with 0.0023 megagrams over 1. In the next fraction, we put 1 megagram on the bottom and 1 times 10 to the 6 grams on the top. In the second fraction, we put 1 gram on the bottom and 1,000 milligrams on the top. The megagrams cancel out and the grams cancel out. We are left with milligrams, the unit needed for the final answer. Multiplying and dividing all values, we get 2.3 times 10 to the 6 milligrams.